Hey guys, today we are going to learn about angles that can be found inside of polygons. First though, let's talk about what a diagonal is in a polygon. A diagonal is a segment extending from one vertex to a non-adjacent vertex of a polygon. Adjacent means next to, non-adjacent means not next to. So I'm just going to pick a vertex here from this polygon, which happens to have 6 sides, so it's a hexagon. I could draw a diagonal from vertex 1 to 3, because 1 and 3 are non-adjacent. I could also draw one from vertex 1 to vertex 4, or from vertex 1 to vertex 5. But not from 1 to 2, because those are adjacent vertices, which means I would actually just be tracing a side. Same for 1 to 6, I would just be tracing a side, so that's not a diagonal. So I was able to draw 3 diagonals from this vertex. I could actually draw 3 diagonals in this hexagon from any particular vertex. Okay, now if there's more sides, you can draw more diagonals. Okay, so the Polygon interior angles theorem says that the sum of the measures of the interior angles of a convex n-gon, now convex just means all the vertices are pointing outward, the sum of the measures of all the angles. So if I add up the measures of angle 1, 2, 3, 4, 5, and 6, what will they add up to? You can find that by doing the number of sides minus 2 times 180 degrees. And here's why. N minus 2. Now look at this. This has 6 sides, which means N is 6. And when I drew in all the diagonals from one vertex, what I actually did is I triangulated this polygon. I made triangles out of it. And I came up with 1, 2, 3, 4 triangles. 2 fewer than the number of sides. So n minus 2 actually tells me the number of triangles inside of a polygon. Okay, so this polygon has 6 minus 2, or 4 triangles. So n minus 2 is the number of triangles. So for this polygon, that would be 6 minus 2 times 180. And 6 minus 2 is 4. Okay, 1, 2, 3, 4. 6 minus 2 gave me 4. I have 4 triangles inside of that polygon. Now, 4 times 180 is 720. So I know that this hexagon here has 720 degrees inside of it. Now, there are a couple different types of polygons that we just should know how many degrees are in them. You may not know yet, but from this point forward, you should just know that a triangle, 3 sides, has 180 degrees in it. A quadrilateral, 4 sides, has a total among its 4 angles of 360 degrees. Those are 2 easy ones to remember, especially the triangle. Now we want to find the measures of the interior angles of a convex hexagon. So here's a convex hexagon, which we've actually already done. This was a convex hexagon right here. Okay, now a convex hexagon has 6 sides, so n is 6. 6 minus 2 tells me the number of triangles. Okay, so this will have 4 triangles. Now triangles are 180 degrees each. And 4 times 180 is 720 degrees. Okay, now it doesn't matter what vertex I pick. For this vertex right here, I could draw 1, 2, and 3 diagonals, giving me 1, 2, 3, 4 triangles. Each one is 180 degrees for a total of 720 degrees. You do not have to draw in the triangles every time. And more sides means more triangles. We don't want to do that as the number of sides gets larger. So here, I've got a decagon. That's 10 sides. I do not want to draw in all of the diagonals to count the triangles. So I'm just going to know that 10 minus 2 gives me the number of triangles. And each triangle is 180 degrees. So that's 8 triangles times 180 degrees. And 8 times 180 is 1440. So I know that every decagon, every convex decagon will have a total of 1440 degrees. Now here is a quadrilateral. It's got 4 sides. Find the value of x. Now I know a quadrilateral has 360 degrees total. Okay, what if I forgot? All right, so there are 4 sides. Take away 2, that tells me the number of triangles, times 180 degrees per triangle. So that's 2 triangles times 180 degrees. That's 360 degrees. So I know there will be 360 degrees total. So if I add all 4 angles, x and 71 and 112 and 135, I know it's going to be a total of 360. Now let's combine these like terms here. 71 plus 112 plus 135 is 318. So x plus 318 equals 360. Minus 318. So I've got 360 minus 318 is 42. So x is 42. Okay, now in this diagram, we want to find the measures of angles K and L, and these arcs actually tell me that K and L have the same measure. So I'm just going to call them both x. Okay, so if I combine all of these 5 angles, well, first I need to know how many degrees that should be total. So here's how I find that out. There are 5 sides, so n is 5. It's a pentagon. 5 minus 2 tells me how many triangles I can make out of it, and each triangle is 180 degrees. 5 minus 2 is 3, so it's got 3 triangles at 180 degrees each, and 3 times 180 is 540. So I know that this will be a total of 540 degrees. Okay, now before I write the equation, let's actually just combine our like terms. I've got x and x, so that's 2x. And then I've got 68, 105, and 109. 68 plus 105 plus 109 is 282. So 2x's plus 282 gives me a total of 540 degrees in this pentagon. So minus 282, okay, 540 minus 282 is 258, and divided by 2 is 129. Okay, so x is 129, so that means that this is 129 degrees and this is 129 degrees. So find the measure of angle K and the measure of angle L. The measure of angle K is the same as the measure of angle L, 129 degrees each. Okay, now what if those angles are outside the polygon? So here is a pentagon, 5 sides, 1, 2, 3, 4, 5 sides. It's a pentagon. And each angle, each vertex has an exterior angle drawn with it. No matter how many sides I have, if I put one exterior angle at each vertex, these exterior angles will always add up to 360 degrees. So we want to find the value of x in this diagram, and these 4 angles are exterior angles, which means they will definitely add up to 360 degrees. I don't care if it's got 3 sides or 1,000 sides, the exterior angles always add up to 360 degrees. Okay, now let's combine our like terms. X and 2x makes 3x. And then we have 85 plus 89, and that's 174. So 3x plus 174 gives me 360 degrees for my exterior angles. So I'll subtract 174 and get 3x equals 360 minus 174 is 186. And divide by 3. 186 divided by 3 is 62. Find the value of x. The value of x is 62. A convex pentagon, so that's got 5 sides, has exterior angles. Okay, exterior angles tells me 360 degrees total. 4 of those have measures of 66, 77, 82, and 62 degrees. What is the measure of the 5th exterior angle? So I have a 5th exterior angle of x degrees. My other 4 are 66 plus 77 plus 82 plus 62, and that is 287. And exteriors always have a total of, I wrote this backwards, we'll scratch that out, 360 degrees. So minus 287. So 360 minus 287 is 73. Okay, so x is 73. Now it does not say find the value of x. It says what is the measure of the exterior angle at the 5th vertex. That measure is 73 degrees. Okay, we're going to end the video here for today, and in our next video we will be able to name or classify polygons based on some things we might know about their angles, and we'll also learn about interior and exterior angles of regular polygons.